Let me confess, I mean, about the stages when I basically, that I went through after receiving the invitation. First, I was incredulous. I could not believe I had been invited. That was basically. After that, I was super proud of myself. I mean, man, this is I really made it, you know. After that, panic. What I going to tell this thing to this distinguished, basically, group of researchers? And then resignation. I said, well, the audience are going to lynch me. I hope that honey basically protect me. You know? Okay, I'm going to, most of you basically tend to, many of you knows me because of my work on freight transportation systems. But I also have a separate life as a disaster researcher. And basically, two-thirds of what I do in freight is that, and the other third is disasters, disaster response logistics. In essence, what I'm going to discuss here is part of our research on the disaster side that have basically commonalities with the subject of this. In essence, we're trying to define mathematical formulations that capture the essence of the disaster conditions. Essentially, one of the things that we do is that we do pretty much everything on the disaster side. Kind of the same things I do on the freight side. We do field work, data collection, mathematical models, I mean everything that we do. One of the things that we have been doing for many years is field work. I have been at the locations with the biggest events have taken place. Japan, Haiti, Nepal, all of that. I took this picture. Typically, we go to disaster as soon as possible, as soon as we could make it in a safe manner. This is basically a picture that I took in Haiti 10 days after the earthquake. Just to give you a sense about what it means, this is when they started to remove the bodies. That is basically it. And the kind of things I saw here, basically, difficult to recount. In essence, here I survived a civil war. I've seen a lot of things, extreme things, but I never seen something as apocalyptic as I saw in Port-au-Prince. There were basically hundreds of basically signs like this. There was a complete collapse of the human technical systems that make society works. And the question is, how do we optimally distribute supplies? I mean, relief supplies. Now, in essence, a disaster have impacts in basically multifaceted. There are destruction of infrastructure, but at the end, all of this translate into deprivation. Deprivation of supplies, deprivation of services. That is there. And this is basically what produces the most gut-wrenching impact that you could basically see. What is this? Now, through to my way to do things, I try to go back to the essence of the problem. Let's say, if the first thing that we did here was to try to study what research has been doing, assessing the impact of deprivation. In essence, we went through the literature, and we found out that after the World War II, pacifists that basically refused to go to the war because of the principles, they basically volunteered to participate in experiments. It's called the semi-starvation experiment that basically took place in Minnesota, if I remember correctly, because basically they wanted to identify how to bring back to life all these people that had been starved almost to death. And basically, there were a couple of important things were found. This is basically non-linear effects. The deprivation produces effects that are basically non-linear, and also tend to produce long-lasting consequences. Now, we also took a look at the philosophical considerations. Some of the topics that we have been discussing during this. In essence, because one of the things that we wanted to do was to evaluate, to assign some sort of a numerical score, a cost, whatever, in order to be able to evaluate suffering. And I knew from before doing the first step that this is going to be a very conflictive topic. And basically, we went through the literature, distributed justice, to try to understand how to do that. In essence, one of the key conclusions is that there is no clear, universally accepted way to do that. Now, being the pragmatist I am, this is my rule. It is better to be approximately correct than basically being completely wrong. And this is basically one of my guiding principles. Welfare economics. In reality, welfare economics is the branch of economic that study the effect of allocation of resources, which is exactly at the heart of how to distribute supplies. Yes. Now here, the challenge is that markets collapse. Here, we know that this cup of coffee, might be $3 because there's a market for that. But in disasters, markets simply, poof, go kaput. And basically, that means that there are needs, the supply of supplies basically disappear, the demand is distorted, among other things like panic. That, by the way, one of our latest round of research on the so-called panic buying clearly showed that there is nothing panicky about this. In essence, it's basically myth. In essence, from the collapse of the markets, create a situation in which the effects on the survivors are simply economic externalities because nobody accounts for them. That's basically, and that is the framework that we follow. Now, if we talk about welfare economics and we have externalities, we need to move to the domain of social costs. That means the private costs are those that are basically internalized by the participants in the economic transactions, and the externalities are basically all these effects that simply are not captured by the markets. Now, in essence, why social costs? Well, we have the relief groups, there is an environment, and also the beneficiaries. All of this, what the relief groups take into account is basically the traditional costs associated with the logistics. Now, there are basically impacts on the environment, you see, that typically are basically nobody cares much about that. And then we have basically the effects on the impacted populations. Now here, there are basically like a web of effects. In essence, we have those who get aid. There is an improvement to them. There is a reduction in the suffering. But guess what? Since the supplies are basically typically like a small portion of the needs, for everyone that get goods, there are basically 100 that do not. And basically that is a secondary effect. Because for everyone that gets the things, all the others, the suffering increases. In essence, one of the things I wanted to, when we began reading about this, when I look at the formulation traditionally used in the humanitarian and the logistics domain, didn't take that into account. Suffering. Essentially, what we try to do here is to provide a metric about suffering. That is something controversial. People are telling me, but I mean, this is obscene, basically. How could you evaluate this thing? Well, because if we do not evaluate it correctly, any allocation of resources is going to be misguided. That's basically it. What we decided to do here was basically to use economic valuation techniques. And the techniques that we use to assign economic value to non-market goods. That's basically it. Now, conceptually speaking, suffering, the deprivation cost functions are basically a proxy for suffering. These had to be monotonic, it's always going up, non-linear, had to be convex, and had to be associated with not additive demands. Let's say if you are hungry for 5 days, I mean, you do not eat the food that you have eaten in 5 days. You see, that's basically it. And also had to be hysteretic. What is this thing? Essentially, let me explain further the non-hysteretic effects. In essence, it all boils down to the relation between the deprivation cycle and the fulfillment cycle. In the case of the non-hysteretic behavior, we have a deprivation cost. That is a function of parameters, the characteristics of individuals. If you're a pregnant woman, basically your deprivation costs are going to be different. If you're the elderly, etc., etc. It depends on the characteristic of the individual. Now, what you have here, this is basically the deprivation cycle. Now, in the case of the non-hysteretic behaviors, I mean, if you satisfy the need, basically it goes back to the origin. Now, in the hysteretic case, which is basically the toughest and probably the most realistic in extreme conditions, basically it's behavior like this. I mean, you go up, and then there is a penalty. There is an effect. It's an effect. That's basically it. Now here, I mean, this is the most realistic, but it's simply, I mean, there is no way to easily estimate this. That most likely that will need basically biological research.
So just for intuition, is hysteretic behavior like a post-traumatic stress or
you could have and also physical damage. You see, basically, you don't go back to normal. That's a cost. That's a penalty on that.
So can it be monotonic and hysteretic?
Well, in the case of hysteretic, it's not. That's the covenant of monotonic applies to this one. You see, and basically you could back, and this is basically the case of let's say soldiers and people that experience basically extreme deprivation. You see, that's basically it. How to compute this? Beats me. Okay. Now, on top of that, we have here path-dependent effects. You see, imagine if you have one truck making deliveries to all these locations. Well, I mean, the lucky ones benefit. I mean, basically the deprivation functions, I mean, it moves to the right. But what happens to the others? I mean, the deprivation increases. You see, and if you do the same, it's basically, it's a combinatorial problem. It's non-linear, and on top of that, it's path-dependent. At every step, the cost in the network changes. It's a super difficult problem. Now, objective function. In essence, in the humanitarian domain, there are basically two different cases. We have what I call the what I define as the regular humanitarian logistics. It's basically deliveries to Somalia, basically a non-conflict region in which the idea is to deliver goods as part of a routine delivery, a process of aid. Now, in the case of disasters, these models do not apply to disasters. Why? Because in disasters, as we have established, there are basically a number of emerging effects. I mean, there is no communication, particularly in the catastrophic event, this is basically our specialty. All signs, all functioning systems are gone kaput. No Facebook, no electricity, nothing. Collapse of the governments. In the case of Haiti, in Haiti, this is typical case in catastrophic events. The senior leadership of the peace force organized by the United Nations, the senior leadership, were in a meeting, all of them died. The bishop of the Catholic Church, killed by the worker. The 13 or 15 of the 15 buildings that housed the different ministries in Haiti, they were completely demolished. In essence, the country was decapitated. I mean, this is the kind. In essence, normal sense, basically, you are going back to the basis. Disasters and catastrophic events are basically major equalizers. Bill Gates, Elon Musk, they are as good as the other guy. This is basically the level of. In essence, there are a number of proxies. I want to go quick because in essence, what is one of the basically variable penalties. What they try to do is to approximate the real suffering. Now, in reality, I mean, these piecewise penalties, nobody could guess them. Okay, you see, it's not something that we could do as a mathematician, basically to come up with that. In essence, if these penalties match the deprivation cost function, they work. If not, completely inappropriate. If we have constant penalties, in essence, you can see here the effect. I mean, no good. Equity constraints, they simply say, well, you need to have you are going to get a set delivery, a given the time without resources, kind of something like this. In essence, if we go to all of them, unmet demand, they don't take into account the amount of deprivation, the deprivation time. All the things, good proxies for the, let's say, the regular humanitarian logistics, let's say, delivering to cases in which the needs are not so extreme, but for disaster, completely incorrect.
So what is the reason that the need to potentially triage is neglected here? So, like, you assume these functions keep on going forever, right?
No,
but in reality,
just wait, and then you'll see.
You'll come to that. Okay.
Yeah.
Okay.
That's
yeah.
That's
okay. Okay. Yeah.
Yeah, that's. No, basically, in reality, triage takes place.
Right, but that would mean that these functions would stop to rise, right? At some point, the cost would.
No, people die.
Right, exactly. But there might be scenarios. No, it's very sad. But there might be scenarios where you might have to accept.
And these scenarios happens all the time.
Right, but then this function has to stop to rise. It has to level off, right? So the suffering when the person is dead.
That basically, in economic terms, that stop at the value of life.
Right. Okay. Yes. Right. Right.
Stop.
But still, that is not assumed here, right? This is assumed that they keep on rising to infinity.
No. We constrain that in essence.
Yeah.
After 5 days, I'm going to show you the deprivation cost function for water.
Okay.
After 5 days, most people die.
Oh, so that is factored into the shape. So it
Yes,
levels
sure.
off at the value of life.
Yeah, that's I mean,
Okay.
people die.
Yeah, right.
Yeah. Social cost. What we try to do here is basically develop like the steps, what nodes to visit, nodes being concentration of people, at what time, how much goods to do, etc., etc. I'm basically going to simplify all of this by this gamma xt, like a mathematical operator to simplify things. We also need to account for the terminal period, because in essence, in order for proper modeling, you need to obtain the deprivation cost at the end, because otherwise you get erroneous results, which is basically this. What we have here is at the logistic cost and then deprivation cost. I will show you later like a formal model, but in essence, the good thing about this is that we do not take into account, we do not have to specify the level of service, because depending on the capacity to distribute things, the optimal level of service is going to go up or down. Okay? Now, in essence, what these things do is that there is an increase in deprivation. If you fulfill the needs, reset to 0, and then go back. If you do not have enough goods, then there will be a partial fulfillment. Okay, and so on. In essence, this is basically at the heart of the formulation. Now, interestingly, one of the things that the people have told me, Jose, but the results are going to be dependent on how well the deprivation cost function is estimated. What we found is that if the deprivation cost that we have is basically dominate the true function that nobody knows, the solution is going to be the same. Believe it or not. Because in essence, because of a property that I'm going to explain 3 or 4 slides away. And you're going to see why. Because in essence, because of the nature of the solutions that I'm going to explain in a moment. Now, if you compare all the things, this is basically the social cost model, and basically all of them are different. You see, they produce different results. Okay. Now, if the deprivation is basically minimal, the difference in all of them are basically basically it might be small. Numerical results. This is basically the first one the first deprivation cost that we computed, and basically in essence the optimal. If you allocate resources to a given population, the deprivation cost for the others increases. How do we minimize this? In essence, ensuring that everybody share the suffering. See, that is what, in essence, this is what we call the socialization of the suffering. You see, in essence, there is a period here, always a period of kind of like a transient, but at the end, this is the optimal solution. In essence, ensuring that all populations suffer the same amount. Needless to say, if that doesn't happen, this is basically what happens if we solve this small case basically with delivery costs. In essence, the replication of this without, it's basically for sure lead to a situation in which the deprivation cost of some of the nodes is skyrocketing. Because it's impossible. If your function doesn't account for this non-linear behavior, it's impossible for any of these simplistic functions to work. Now, the key insight is basically this thing. Needless to say, I was super happy. I was so proud of myself. Man, Jose, important insight. But guess what? I was scooped by no other than Adam Smith. Believe it or not, 200 years before my super act of genius, he basically found the same. By the way, I wrote a paper last year in which I basically included this quote, and one of the reviewers said that this paper deserves to be rejected for quoting a non-academic journal that was written more than 200 years ago. How could you say this? And the guy was saying that I am wrong for citing the father of modern economics. Could you believe that?
It was probably reviewer 2. That one is always the problem.
Because this is a non peer review article. I don't know. I better stop talking about this. Deprivation cost function. How do we examine all the wide range of techniques, and at the end we decided for a willingness to pay approach. In essence, contingent valuation, in which you ask people, how much are you willing to pay for water? In fact, we focus on water, drinkable water. Now here, this technique, willingness to pay, has a problem. That typically, if I'm a wealthy person, I could pay thousands of dollars for a bottle of water. And the guy next to me, that is a low income, basically cannot do the same. Now, in order to deal with that, we basically, understanding the magic of econometrics, we constrain this. We added to the experiment a constraint, the budget. We gave all the participants, basically, in essence, as part of the stated preference scenario, we told them, you have X amount of dollars. That, by the way, this is basically what happens in disasters. In essence, whatever you have in your pockets, that is what you have. There are no ATMs, there are no cell phones to work. It's basically, that is what you have. Now, why do we do that? Because the inclusion of budget as an experimental variable allows us to remove the effect of income and focus on the effect of the deprivation. Results. This is basically a model of willingness to pay. This is the effect of budget here. In essence, the more budget you have, the more you pay. Now, if you take a look at the parameters of the deprivation, this is basically, this exponential, this is the effect of deprivation. In this case, 0.099. Now, if we estimate the model without budget, look what we get. In essence, these parameters are almost identical to the one before, because they, in essence, that indicated to us that we have successfully removed the effect of budget. And this is basically what we call deprivation cost functions. This technique has been applied in dozens of cases. Valuation things like emergency services, ambulance services, etc., etc. In essence, this is basically the estimated decision, the estimated deprivation cost functions. Here, for consistency, we also included what we call a terminal point. In order to make them consistent to valuation of life, we added an extra point so that the at 120 hours of deprivation, basically the value of deprivation cost equal the value of life for 3 different scenarios of value of life. They are basically the ones here. And we have been, since the original publication, have been using this concept of social cost minimization in a whole bunch of cases. Inventory allocation, basically if you have, how do you deploy, how you assign goods, and how do you deliver. Optimal access restoration. I mean, the first step in disaster response is to open access. If there is no, if you don't open access, you need to remove the debris. When I went to Japan, basically, in all the cities I went to, there might be maybe 14 feet of debris. You see, you need to open access. And how do you open access influence the social costs that will take place? If you do not open access in the optimal fashion, I mean, the response will be misguided. Optimal districting. One of the problems that we have seen in disasters, there is competition among the relief groups for basically trying to go to the locations portrayed by the media because they get coverage that they need to get donations. You see, one of my doctoral students, that is now a faculty member at Georgia Tech, basically develop a mathematical formulation to obtain the optimal location of point of distributions, taking into account the reality that the beneficiaries, they move. As soon as they realize that their location has been impacted, that there is very little prospect of aid, they move. In essence, this is basically we need to account for all these unique behaviors. In this case, this is basically an inventory and allocation model. In essence, what we're doing here is allocating supplies and routing. Right. Super complicated, in essence, because of the path-dependent aspect. I mean, terrible. But we found a way exploiting the socialization of the suffering. Because in essence, on the basis of these insights, if the goal is, in essence, if the key principle is to ensure that everybody suffers the same, the problem reduces to find out what are the frequencies and the amount of supplies that you should give to different nodes so that all of them, the suffering equalizes. And this is basically how we solve this. In essence, what you have here is a mathematical expression taking into account the effect of a delivery and also the time to consume the goods. And basically these things work like a charm. In essence, it's like a heuristic, yeah?
Just want to clarify this notion of suffering equally. So different groups, for example, elderly versus...
Absolutely.
So do you measure the amount? Is it relative to how much? I mean, the elderly could die sooner, right?
In essence, different individuals have different deprivation cost functions. I mean, that's a granted. Now, the problem is that we do not know who they are. In essence, basically, in a situation like this, they are basically observationally the same. Because we simply cannot know what is the composition of the elderly. It's impossible. You see, and this is a problem that has no solution. You see, that's why we treat the beneficiaries as observationally identical. Okay.
An actually related question: under what circumstances that principle would not hold? Right. Another thing that I think of is that I think it was in Nepal or something, where they had to say we have to focus our aid on sort of Kathmandu and the areas because the remote villages we have no chance of reaching in time.
Let-
So let's
let-
forget this.
I was in Nepal.
Sorry?
And I know the case. I went to Nepal.
Yeah, right.
No,
I mean, it doesn't matter that it's Nepal, right?
No, no,
What's
no,
more
no, no.
important is,
No, no,
isn't that also a circumstance where the principle would not hold?
No. Let me clarify Nepal, because I know Nepal super well. It's Nepal was a very, very interesting case, because the people there didn't need supplies. Because they are basically self-sufficient. People
Right, then my question is not about Nepal, right? But you could have a situation where the cost to reach people in time would be so high that the better solution would be, let's give up on them.
Whoever told you that is mistaken.
That's right.
Whatever the source of that is mistaken. In essence, one of the most important discoveries that we have done in this is the existence of emergent networks. Emergent networks of volunteers that are basically that deliver supplies at a speed that beats the hell out of any major organizations. In the case of Nepal, we documented, they have basically emergent groups. In some cases, people that barely know each other, that basically they got backpacks and they go to make deliveries. In the case of Nepal, the World Food Program completed his assessment of needs 10 days after the earthquake. By that time, all these emergent groups were already delivering supplies. You see, and these people reached the impacted population weeks before the WFP.
This is super interesting, but again, that's not my question.
Okay.
My question is, there must be circumstances where having everybody suffer the same way cannot be the correct solution.
Why? Give me an example.
Well, Samitha's example, right? If you knew that this is a region where you have more elderly, right? Like people, you know, if you knew that would be an example.
Wait.
There must be other.
You're confusing two things. Given the knowledge about the deprivation cost function, if we have information about everybody here, perfect information, the principle applies.
Okay.
Because basically, the individuals that have a higher suffering, because let's say the elderly, that basically is going to dominate. You need to provide a better service to these individuals than the others, and the whole thing will equalize. Yes.
So it will be steeper, but it will go up to the same point.
No, in essence, if you do not take care of all individuals, the deprivation costs are going to skyrocket until the person dies.
Okay.
In essence, if you have perfect knowledge about the deprivation costs of all the individuals, the ultimate policy is to invest resources in saving the people in the worst condition. You see, that is basically the under this framework.
So there is no scenario where you would need to do triage, where you would need to say we give up on those people.
It depends. If you have, let's say, a triage is basically a decision about benefit and cost.
That's right.
You see, in essence, just to explain the case, typically 3 groups. There are individuals here that, regardless what you do, are likely to die. There are, and the other end, individuals that the suffering is very small. In essence, what triage does is to focus on those in the middle. You see, in essence, what you're saying here is basically this is consistent with triage.
But wouldn't that mean in the triage that not everybody suffers the same?
No. But in the case, but in essence, we are talking about here about delivering supplies, delivering or any other service. You see, because what happens here, this is basically, there might be cases in which, let's say, somebody has to die. You see, in that case, because otherwise, the question is, how many people are going to die? Are going to in that case, basically, there might be like a singularity, I would say.
I think it seems to me
Yeah.
Then it's referring to a corner solution, and the principle apply in an interior solution.
Yeah.
Question, what's the question?
I think that there must be some scenarios, some situations. Yeah. Oh, so sorry. That corner versus interior.
Yeah, I think if
Yeah.
you look at the solution, and then if
Yeah.
you look at interior solution, then interior points, then that principle apply. So the equalize suffering over
Yeah.
the solution. But then there could be a corner situation that some
That basically-
has been done.
Well, if the decision is basically it depends. It depends also in the amount of supplies, because if you have enough supplies, you see. But there might be cases in which basically it depends on what will be. If you have masses of people that might benefit from that in a meaningful way, because basically in order to reduce the suffering because of lack of water, you cannot simply give a person a drop of water. You see. It might be, there might be, but it's like a...
That makes sense, right? So some have zero, right? That's the ones that are sparsity, right? And the other ones, there you get the principle applying, right? Of equal suffering. Okay, that makes sense. Yeah.
Now, what is the implication of this to the... in fact, now we're going to talk about the topic discussed by Jafen. Essentially, in transportation, we focus, you use the concept of consumer surplus. That's a metric. And basically, and the one that is most frequently used is what's called the Marshallian definition of consumer surplus. It happens that at the time, there was a debate between Marshall and Julius Dupuit. But that was a civil engineer, by the way, that basically he said that the best metric of consumer surplus is utility. Now, at the end, Marshall, that was in Cambridge, basically dominated. And that was kind of like a bit of a tragedy in economics, because that definition of Marshall had a lot of problems. That is basically lead to Hicks explaining the concept of compensating and equilibrating variation that Jafen is defined yesterday. In essence, the key problem with the Marshallian definition is that it focuses on the cost. And basically, and that leads to some sort of a nonsensical situations. If you open a new road, basically that increases the utility of the potential users. But from the standpoint of Marshall, this is an increasing cost. Because before, nobody used it. That's basically the... in essence, this is basically the... you had the demand. And basically, what Marshall said, people here are willing to pay that amount, and the market is here, they save this. And if you integrate all of them, this is basically the saving to the consumers. The producers are here. They are willing to produce here, but the market price is higher. This is benefit of all the producers. And the combination of the two is what we call economic welfare. Okay. Now, how do we compute benefits? Essentially, we compare the impacts on consumer surplus with project and without. And basically what you get is this area here is the change in consumer surplus. That is a metric of the benefit produced by that particular improvement. Now, these things could be, this is basically what we do routinely in transportation to assess when we are doing a cost-benefit analysis. Now, in the level of networks in which you have a whole bunch of origins and destinations, and if we assume that this area is like a trapezoid, you get the root of half, which is basically this one. However, these things have the values, the benefits depend on the cost. If you have projects that benefit the wealthy, they will produce by force higher economic benefits according to Marshall, than another project that affect low-income communities. Now, from the standpoint of utility, as Dupuit wanted to define it, the utility of a transportation improvement for the low-income people is larger than the one for the wealthy ones. In essence, that takes me here to a topic of that is it's a topic of contention among the economists, because in essence the idea during the 1960s and 70s, the assumption was, I mean, the World Bank, for instance, developed procedures to assess the economic benefit of projects. And basically, the idea, at the core of this idea was the use of something called shadow prices. In essence, it's an artifice to account for the fact that the marginal utility of income changes. It's not constant. And basically, in his lecture yesterday, basically, Jaffen presented the generalized Leontief. That is basically it's a model developed by Vasily Leontief, who was never in Nobel Prize economics, former from the former resident of the Soviet Union, and then the translog, basically production functions, because these functions account for the changes of the non-constancy of the marginal utility of income. In essence, the assumption here in the 1980s, basically all of that was abandoned because, as I said here, a rising tide lifts all boats. But guess what? The low people have no boats. You see, that is the reality. Now here, the typical shadow price is a function of income. Essentially, for a given population is the average of the population, in this case 75 units, divided by the income of a given population strata. As you can see here, if your income is 10, any project that benefits you is going to be the economic benefits for them. It's going to be multiplied by a factor of 7 in order to bias the decision towards projects that benefit the low-income individuals. Now, if you have an income higher than the average, basically your benefits way less, which makes sense. Okay. This is basically the logic behind shadow prices. Why do I mention this? Because I'm not equity. Well, guess what? Equity is an externality. We do not value how specific segments of the population are well treated or not. We are not account for this. In essence, it's an externality. But guess what? Almost all these equity elements, all of them are correlated to income. What that means is that income is a good proxy. You see, in essence, this is basically, in essence, shadow prices based on income, and they're not going to be perfect, but guess what? Let's go back to my principle. I mean, I prefer to be, approximately correct than completely overlooking a tremendous problem. And basically here, my conclusion to all of you is that income or wealth, you see, they are pretty good metrics.
That's a very pessimistic message, right?
No, this is reality, my friend.
But this means
This is basically.
but this means you cannot build an equitable transportation system unless you make the wealth / income.
No. They basically, I am not saying that. All of you, basically, in all the presentations, all of you concluded, basically, using utility is bad. It's bad because it reduces equity. Because all of you embedded, maybe with the exception of your friend, all of you assume that a unit of suffering for the poor is the same as the one for a wealthy. That's it. You see. In essence, this is a good proxy. Now, if you find anything easier to and less consistent or more consistent, tell me and I will invite you for a beer. Now, you have to convince me, okay?
Just to be clear, so is what you're saying instead of
So do you have more on your talk, or should we? Is that
No. I have maybe two more.
Okay. All right. Yep. Go ahead.
So just to be clear, so what you're saying is in the objective function, you should optimize for wealth?
No. When you account for the effect of different strata, in essence, in order to consider equity, you need to have different population strata. Otherwise, we're not doing much. In essence, use these shadow prices. You see, give me credit for this, by the way, in the papers as well. But basically, use shadow prices to adjust the metric of impact that you're using. You see, basically,
It's a scaling factor.
it's a scaling factor. You see, that's basically it.
I say if you're in Manhattan, right, and you have to take the subway because that's the fastest option that gets you where you got. It doesn't matter whether you're Bloomberg or some poor guy. If two trains break down, right, and you have to wait for half an hour in the cold station, the rich guy suffers the same way as the poor
black
guy,
limos.
independent of the income.
They have black limos.
No, because they take forever.
No.
What if that guy loses his
Bloomberg
job?
takes the
Bloomberg's
subway.
not losing his
I mean,
job.
that's well documented.
No,
No,
that's it.
He does.
But basically, this is basically 1 out of 100.
down.
Okay.
Wait, that's not worth a beer?
No. Conclusion. In essence, in my experience, economics is far from perfect. I mean, however, economics provide a framework to study these type of problems that I haven't found anything better. If you understand the limitations, I mean, economics is the way to go. Now, do not expect to have super accurate predictions, but again, the field is super solid. In my view, welfare economics, basically try to familiarize yourself with that. It's a fantastic tool. It's consistent, and for problems like this, is the only way to do it, in my humble opinion. So references, I had problem with EndNote, and the only basically I have a whole bunch of them, but I know what happened. And with that, basically, I want to thank you for your attention.